Now we will calculate the equity risk premium through historical approach. So first, actually, we need to find the historical yields on 10-year US Treasury. You can go to FRET and do these modifications, modify frequency to annual, and aggregation method will be end of period. And then, of course, you can download the Excel data. Again, the time period will be starting from January 1st, 1973, and it will end on December 31st, 2022. So now we will be having the yields on 10-year US Treasury for this time period of 50 years. And then remember, for the historical returns on S&P 500, actually we are always relying on investing.com because data on FRED doesn't cover the time period, and Yahoo Finance doesn't allow to download the data. So if you need to get this data free through a public resource, actually investing.com provides that data to you. And again, we rely on the data on investing.com for historical returns on S&P 500. There is no annual option here. Time frame will be monthly. In this drop-down menu for the time frame. So use monthly and then calculate the annual returns accordingly. Again, the time period we will be looking at will start on January 1st, 1973 and will end on December 31st, 2022. Again, you can easily download this data from investing.com. But remember the problem from the previous problems. When you download this data from investing.com, actually this date column will start from the earlier date to the oldest date. So you need to sort this column. So select sort function, sort by date column, sort on cell values, but order will be oldest to newest. So it should start from 1973 and end in 2022. And of course, because we need the annual returns and the data is monthly, you can filter all months except January, because now we will be looking from January to January. We will be able to look at the data in an annual manner. So here you have the data. Select the filter option on Excel, and here just click on this drop down and select month and just enter January in here, then click on OK after filtering for January. So then you will get this data. So finally we get the data we need. Now we can calculate annual returns on S&P 500 from January 1973 to January 2022. So just use these price values and calculate the annual returns on S&P 500 for this time period of 50 years. And of course, these are the calculations. We have the data. Just calculate the annual returns on S&P 500 throughout all these years. And average of these annual returns will be the expected return on S&P 500, which is around 9% or so. Of course, if you want to calculate the variance of these returns on S&P 500 and standard deviation of the returns on S&P 500, you can calculate deviations from the mean. These are annual returns minus average for each of these observations. These are deviations from the mean. And of course, we are just squaring the deviations from the mean to calculate the variance. Variance of the returns on S&P 500. Remember, we can sum them and divide it by number of observations minus 1 because we are following the sample function, or you can just use quick exact functions. Variance S will just solve the variance problem, and this is also true for the standard deviation. And do the same for the yields on 10-year US Treasury. Calculate the annual returns and calculate the expected mean return on US Treasury at 10-year, and deviations from the mean again. These annual returns minus this average return. This will be the deviations from mean for each of the observational point, and then we are just taking the square of these values to calculate variance and standard deviation. And then of course you have the expected return on S&P 500 for this time period, and you also have the expected mean return on US 10-year treasury yield. So the difference between these two values will be historical equity risk premium 50 years back, and which is around 5.70%. So with the implied equity risk premium approach, we got something around 4.99% or so, around 5%. So the numbers are close, but they are different. And also look at the standard deviations of these returns for this time period of 50 years. S&P 500 appears to be less risky than US 10-year Treasury, even as US 10-year Treasury has a way lower expected return. We have this expected return at around 3%, but look at the standard deviation, 34%. But here we have a higher return for the S&P 500, and look at the standard deviation, it is around 16%. So for this time period, actually, S&P 500 theoretically is riskier than a US Treasury bond. But here, when we look at this specific time period, it doesn't appear to be the case in here. S&P 500 seems to be less risky than the 10-year US Treasury bond, and even as S&P 500 has higher expected returns, it has lower standard deviation in this historical approach.